All right, in this extra kind of bonus video, we're going to derive the product rule. What we're going to do is set ourselves up to find the derivative with respect to x of the function given by this product, f of x times g of x. And we're going to do this by setting up the limit. Right, so this is the limit as h approaches 0 of, we're going to have a big long fraction here. In the numerator, we are used to thinking about it as f of x plus h minus f of x. But now our function is the product f of x, g of x. So that numerator now looks like f of x plus h, g of x plus h, right, that product, minus f of x times g of x, all over h. Now, we don't have a specific function, right? We have this product of two unspecified functions. So there's not a whole lot of algebra we're going to do, and it seems, when we look at it like this, that we're just stuck. Like, where could we possibly go? But what we're going to do right now is we are going to employ one of the oldest tricks in all of mathematics, and that trick is to add 0, right? We're allowed to add 0 to stuff without changing what it's equal to. And the way we're going to add 0 is we're going to add and subtract the same thing. So we're going to get the limit as h approaches 0 of, I'm going to show you how this is going to work out here. Up top we have f of x plus h, g of x plus h. We know that we're subtracting f of x, g of x at the end. And I'm going to add and subtract in the middle just because it's convenient. So I am going to, in fact, actually, I'm going to subtract first and then add. So I'm going to subtract f of x plus h times g of x. And then I'm going to add it back again. Right? So that is going to end up being the magic result for us, okay? Now we have this limit, and it looks like at first that we just made the fraction uglier, right? Like harder to work with. But this is actually is going to be what makes it work for us in general. And what we're going to do is split up this fraction over this addition right here. So we're going to have the limit as h approaches 0 of f of x plus h, g of x plus h, minus f of x plus h, g of x, all over h, plus f of x plus h, g of x, minus f of x, g of x, all over h. And this is all in this limit, okay? Now, if you look just at the first fraction, we've got a common factor of f of x plus h. So I'm just going to take that out. And then here we have g of x, x plus h, minus g of x. And then in the second fraction, we've got a common factor of g of x. I'm going to take that out. And we have f of x plus h minus f of x, all over h. Okay. Now we have this sum, right, inside the limit, and you can split up limits over a sum. In fact, we've done that before when we were studying limits, right? We just sort of evaluate each term, and that's this equivalent to kind of splitting up the limit over the sum. So I'm going to write this as two separate limits now. The limit as h approaches 0 of f of x plus h times this fraction, g of x plus h minus g of x all over h, plus the limit as h approaches 0 of g of x times this fraction, f of x plus h minus f of x all over h. And not only can we split up a limit over addition, but we actually split up limits over products as well, right? And that's kind of how we evaluate a lot of things. We just say, okay, well, what is this piece going to as h approaches 0? Or what is this piece going to as, you know, x approaches 2, or whatever the limit is that we might be finding. So now I'm going to just split up and have a bunch of limits written out. We got limit as h approaches 0, f of x plus h, times the limit as h approaches 0 of g of x plus h minus g of x all over h, plus, and then here we have the limit as h approaches 0 of g of x times the limit as h approaches 0 of f of x plus h minus f of x all over h. All right, now we're just about done. As h approaches 0, let's do each part on its own. As h approaches 0, f of x plus h approaches f of x. Now, this next limit, the limit as h approaches 0 of g of x plus h minus g of x all over h, that is the definition of the derivative of x, so that's g prime of x. Next, we have the limit as h approaches 0 of g of x, and there's no h in there, right? So it's almost like that, whether or not h is approaching 0, or h could approach anything. G of x is just g of x. So we have a factor of g of x here, times, and then this last one, the limit as h approaches 0 of f of x plus h minus f of x all over h. That is the definition of f prime of x. That's the derivative of f with respect to x. So that is the product rule. That's what we're hoping to get. Right, so there's a demonstration or a proof that the product rule, of why the product rule looks the way it does.